So in previous video we have learned about gradient of vectors with respect to matrices. So here once more I'm just going through that same video, same concept, like how it is being done with the help of an example. So here what we have taken, a function is in the form of matrix multiplication, and that is a matrix is multiplied with the vector x, and the dimension is also being given. So when a derivative is taken with respect to that function f with respect to matrix A, then the dimension can be like f belongs to Rm. So R dimension m by, and the size of A is m by n. Okay, so m by n matrix, it belongs to this dimension m by n. Okay, numerator and denominator dimension based on that. So this is the dimension that we are taking, and the gradient of gradient will be like, we will be collecting all the gradients, collecting the partial derivative of each function with respect to A. And what is that A? A will be a matrix. So in that case, a particular function's derivative, that is del f1 by del A, will be a single row with m by n columns. Okay, it belongs to a real number. Again, it will be a matrix with a single row and m by n columns. And f is equal to, again considering that the function f is equal to ax, which is a multiplication. There multiplication means it will be taking this form, isn't it? Aij xj. That is, if you are having some, consider for example f is equal to ax, and A is a matrix and x is a vector. So x, if it is taking some values like this, that is, it becomes what? A 3 by 3 matrix, and x will be a 3 by 1 matrix. So what will be the resulting result answer? What it will be? You will be getting 3 by 1 dimension, some vector you will be getting. So that is the dimension of f. As we have said, f will be belonging to some set of real numbers having the dimension m. So here m will be like, it is 3. Okay, a single column vector with 3 elements. So our task is, we will be derivating this f with respect to A. F with respect to A we will be derivating. So f is a vector, A is a matrix. So what will be the dimension? F is now, it is of size 3. So which belongs to set of real numbers of size 3, that is 3, and A will be what? The matrix size, that is 3 by 3. 3 by 3. So this will be the dimension of derivative del f by del A, if we are taking the partial derivative of any function with respect to A. So next, how to find the partial derivative? In this example, f is 3 rows and 1 column, isn't it? So f will be having some set of values. After performing the multiplication or something, you will be getting the values with the 3 rows. You will be having del f1 by del a1, you need to find, then del f1 del a, del f1 f2 by del A, and finally del f3 by del A. So these are the partial derivatives that you need to find. Okay, and cascading all this, you will be getting what? The gradient. So how to find that? So in this case, A is a matrix. So here you are differentiating a vector value f1 with respect to A. A in പറയുന്നത്, it is a matrix, isn't it? So this can be found like del of F1 by del A11, F1 by